Our next question, what percentage of US presidents are over 59 when they're inaugurated? Well, again, using the normal density function, we're going to convert into z-scores. So we'll start with our 59. So the observation is 59. We're going to subtract the mean of 55, and we're going to divide by our standard deviation of 6.6. So we're going to change that 59 into a z-score. So the numerator, 59 minus 55, that difference is 4. So we're just going to take 4 divided by 6.6 in order to get our z-score. So that's a z-score of 0.61 if we round to 2 decimal places. So to use the model, again, the best way to show your work is to draw and label a picture. So the shape that we are using is the normal density function. And to represent that, we need to recognize that since we're using z-scores to make this a density function, the mean is 0. Z-scores have a mean of 0. The standard deviation is 1. Z-scores have a standard deviation of 1. And we're interested in using 59 as a boundary. So what percentage of US presidents are over the age of 59 when they are inaugurated? So that's a z-score of 0.61. We'll put it right about here. That will be our boundary. And I'm interested in values over that. So we're going to shade then to the right. The shading is an important part of showing your work because it illustrates where the percentage is that you are trying to find. So understand, when I need to use the shade norm command, I need to specify a lower and an upper boundary. The lower boundary is always on the left, the upper boundary is always on the right. So this time the 0.61, the z-score I've calculated, that's the lower boundary, and there isn't an upper boundary specified. So if I want to include as much of the distribution as is plausible here to the right, in order to capture that area, most of the area we've already accounted for by the time we get up to a z-score of 10, an upper boundary of 10 standard deviations above the mean. That's more than high enough in order to get an accurate area here, an accurate representation using this model. So to do this, we're going to use the shade norm command. So we'll press the second button, the variables button. This takes us to our distributions options. We'll go to draw, and there's the shade norm command, option number 1. So this time our lower boundary is our z-score of 0.61. The upper boundary is the z-score of 10. You could put in 100, you could put in 1,000, put in 1,000,000 if you want. So we don't want to change the mean and standard deviation. 0 and 1 are the default mean and standard deviation because those are the mean and standard deviation for z-scores. So again, the picture that you are drawing should essentially match the picture that you're going to see on the calculator screen. So the area that we found using a lower boundary of 0.61 and an upper boundary of 10 would be way over here, that area is about, what, 0.271 is what it would round to, so about 27.1%. So you should always make sure to go back and label it. So the actual answer, the percentage of US presidents over 59 when inaugurated, we'll call that about 0.271. Again, that's the answer that we get using the shade norm command. That's the answer we get using the model. So we can actually go to the data and see what the real value is. So the actual value, I'm interested in presidents that are over 59 when they're inaugurated. So we've got those values. Here I'm on the drawing screen still. So before I go look at the values, I'm going to go to the home screen. And I'm also going to clear the drawing. Second program, enter, enter. So I don't forget to do that later. So now I'll go look at the data. I'm interested in how many of these presidents are over 59 when they're inaugurated. So these are at the other end of the distribution. So a little trick, if you want to go to the bottom of the distribution, we put these in order. If you press the up arrow, it'll actually take you to the bottom. And I'm going to keep pressing the up arrow until I get to what I'm looking for. I'm interested in the count of presidents. Here we go, the count of presidents that are over age 59 when inaugurated. So the first one is this president who was 60. So I'm going to count those observations. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So Trump is the last one at 70. So we have an actual percentage of 11 out of 45. So we'll see what that is. I think we're going to be pretty close here. So going back to the home screen so we can do our math, 11 out of 45. That gets us a percentage of about 24%, 0.244. So that's the actual value. And again, the model's pretty close. A mathematical model isn't expected to be a perfect representation of the data. It's a model, it's an approximation for the data, and frankly, this one's pretty good. So something to think about when you're doing a calculation that involves over. So over 59, or even if this was an under question, I have a lot of students that wonder, oh, well, wait a minute, if I'm interested in presidents that are over 59, what observation should I put here when I calculate my z-score? Should I put 60? 60 minus 55 over 6.6? 60 is over 59. Well, but something to think about, over 59, 59 years of age actually means exactly 59 years of age. We don't mean 59 years, 211 days, 5 minutes, and 12 seconds. We literally mean 59 years of age, spot on the nose. 0 seconds, 0 minutes, 0 days. So the truth is, being exactly 59 years of age when you're inaugurated for all practical purposes has 0 probability. So, and the reason to think about that, look, you can think about this in terms of area. In number 3, leave 59 as your boundary, because think about this. 59 is the appropriate boundary because the model says that there can be no area or 0 area between z-scores of 0.61 and 0.61. Understand the z-score for 59 is 0.61. So how likely is it that a president is between 59 and 59 years of age? Well, there is no area between a z-score of 0.61 and 0.61. There's nowhere to shade. There's no area. So, and that's because the likelihood of being 59 spot on the nose years of age when you're inaugurated for practical purposes is 0. So go ahead and use the 59 as the boundary, whether you're including the 59 or not in your question. If this was, what's the percentage of US presidents that are 59 or over? It's going to be exactly the same because the likelihood of being exactly 59 years old when you're inaugurated, for all practical purposes, is 0. So let's try the next question. So what percentage of US presidents are at least 50 but no more than 60 when inaugurated? What makes this question different is now there are 2 z-scores. So because I've got a lower boundary and an upper boundary that are being specified by my ages of 50 and 60 years. So I just need to calculate 2 z-scores. A z-score for 50, 50 minus 55 divided by 6.6, and a z-score of 60 minus 55 divided by 6.6. So this is negative 5 divided by 6.6. So that z-score comes out to be negative 0.76 to the nearest 10th. And something to think about here, notice this z-score represents 0.76 standard deviations below the mean. Well, that's 5 years below the mean. 60 is 5 years above the mean. It will be the same. It is 0.76 positive, 0.76 standard deviations above the mean. The normal density function is perfectly symmetric. So here, 5 units below the mean, 5 units above the mean, they're the same distance, so they should be the same number of standard deviations from the mean. It's just that one is below, so the z-score is negative. This one is above, so the z-score is positive. You're welcome to take 5 and divide by 6.6 if you want to. It's the same thing. So just something to think about. So draw and label a picture. So again, same thing. We're using the normal density function. So this has, because we're using z-scores, a mean of 0. It has a standard deviation of 1. And we are interested in a president that is at least 50 but no more than 60. So again, we can use the 50 and 60 as our boundaries. So my upper boundary is 0.76. I'll put it right about here. My lower boundary is negative 0.76, so I'll put it right about here. And on this question, I'm not interested in the area below or above. I'm actually interested in the area between these two z-scores. So what's nice about this question is you automatically get your lower boundary and your upper boundary. Here's the lower boundary, and this z-score is the upper boundary. So it's no problem. I remember I already did the clear draw command, so we'll go to second variables, draw, shade norm command. The negative 0.76 is my lower boundary. The positive 0.76 is my upper boundary. Again, don't change the mean or the standard deviation. Those are the correct ones for using z-scores. So again, your picture on the screen should look similar to the picture that you have drawn. You've just labeled your picture that you've drawn with the lower boundary, the upper boundary. So here, the area is about 0.553, so that's about 55.3% of precedence. So you should go back and label your drawing. So this area is about 0.553. So let's actually go to the data and see how many presidents are at least 50, but no more than 60. Well, let's go take a look. The actual data, they're already sorted, so I'm going to go back to the home screen. Again, just to have myself ready for later. Second program, enter, enter. I'm going to clear the drawing. Now I'm going to go look at my observations, and I'm going to count the observations, how many presidents that I have from 50 to 60 years of age. So let's see, here's my 50. There's my first 50, so I'm going to count them at least 50, but not any more than 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There are 26. 26 out of 45. Well, let's see what that actual percentage is. 26 out of 45. Go to the home screen. We're only doing this to see how good the model is. 26 out of 45, 0.578. So again, not bad. Not exact, but that's not the point of a mathematical model. So, and again, the reason we have the actual data to work with, if you only have 45 observations, work with the actual data rather than a mathematical model. Models are useful when you have loads and loads of data. At that point, the model makes making conclusions easier to do, and that's where its convenience comes into play.